In the previous video, we learnt about discrete frequency distribution. Here, today, let us cover the topic continuous frequency distribution. Under types of classification, we come across 4 types. Under that, one of the types of classification is quantitative classification. Under that, we have taken this example. How the students can be classified on the basis of marks scored by them. Now, this is continuous frequency distribution. In case of discrete frequency distribution, instead of taking variables in groups, we take the exact value of variable. Like we may take marks as 10, 20, 30, 40, 50, 60, 70, or we may take like this 20, 30, 40, 50, 60, 70, 80, like that. Okay, now here under discrete frequency distribution, we come across 2 terms. One is variable and another one is frequency. Okay, under continuous frequency distribution, in addition to variable and frequency, we come across 3 more terms. You have already learnt variable and frequency. In addition to these 2 terms, variable and frequency, we come across 3 more terms under continuous frequency distribution. They are class limits, class interval and mid value. Now, class limits, you may observe in each class here, this group 10 to 20, 20 to 30, they are called classes, or sometimes we may call that as class interval also, but you take classes, by that you may avoid the confusion between the classes and class interval. Here in this class, you may find 2 values. Means the one is the lowest value and another one is the highest value. Here the 2 values in each class are called the class limits. The 2 values in each class are called the class limits, and the lowest value is called lower limit and highest value is called upper limit. To the class 10 to 20, 10 is the lower limit and 20 is the upper limit. For the class 20 to 30, 20 will become lower limit and 30 will become upper limit, like that. Okay. Now, the next one is class interval. The difference between the limits, these 2 limits of a class is called class interval. That means class interval equals upper limit minus lower limit. Difference between the 2 limits of a class is nothing but class interval. Class interval equals upper limit minus lower limit. When you come to mid value, it is nothing but the average of these 2 limits. Average of these 2 limits means upper limit plus lower limit divided by 2. That's all. Here class interval means difference between upper limit and lower limit, and mid value means average of these 2 limits, that is upper limit plus lower limit divided by 2. Now, under continuous frequency distribution, again we come across 2 methods. One is inclusive method and another one is exclusive method. Inclusive method and exclusive method. Now, whether it is inclusive or exclusive, it depends upon the method of selection of class limits. it depends upon the methods of selection of class limit. We say inclusive method or exclusive method. Now, you may observe here 10 to 20, 20 to 30, 30 to 40, like that. Means here upper limit of previous class is equal to the lower limit of the immediate next class, isn't it? That means in the process of classification, if the limits are selected in such a way that the upper limit of previous class is equal to the lower limit of the immediate next class, it is called exclusive method. Here upper limit is excluded, only lower limit is included. As upper limit is excluded, this method is called exclusive method. Now, when we record the number of events fall in this class, then we consider the values from 10 to 19. Here 20 is upper limit, that 20 is excluded, that is to be considered to the lower limit, that is to the next class. That means if an event actually measures 20, that is to be taken to the class 20 to 30. Here you should be careful. Next, if it measures exactly 40, then it is to be considered to the class 40 to 50, not to 30 to 40. Okay. Now, when you come to inclusive method, then here upper limit of any class is not equal to the lower limit of the next class. You may observe here, means in the process of classification, if the limits are selected in such a way that upper limit of any class is not equal to the lower limit of the immediate next class, that is called inclusive method. Here both the limits are included in the same class, that's why we say it is inclusive method. Means here if an item measures exactly 19, then it is included in the class 10 to 19 itself, because here upper limit is also included. Here upper limit is excluded. Here upper limit is included, it is inclusive method. Upper limit is excluded, that is exclusive method. Now, means under continuous frequency distribution, we may form the frequency distribution table either under exclusive method or under inclusive method. But practically, exclusive method is preferred to inclusive method. Okay. Now, before taking up the formation of continuous frequency distribution, we must be knowing about principles of classification. Okay. Now, under principles of classification, here we under continuous series frequency distribution, we have to group the data, means we have to take the given data in classes. Here we come across class limits, class interval, mid value, all those. Here the class limits must be in multiples of 5 or 10, that is for the convenience. Okay. Then even class interval must be in multiples of 5 or 10. If the class interval is less than 5, then any integral is preferred. Then as far as possible, this class interval must be common. The number of classes must be between 7 and 15, but it is not rigid. Practically 5 to 12 are considered, means minimum of 5 and maximum of 12 are considered usually in practice, because even 15 is considered too long table. Next, as far as possible, we have to see that any frequency should not be 0. If any of the frequency is 0, then we have to reclassify or we have to regroup by changing the class interval, and we have to see that any of the frequency should not be 0. And one more is open-end classes must be avoided. Here, open-end class means here there may not be lower limit of the first class. Then here upper limit of the last class is given. Sometimes here lower limit of the first class may be given, but upper limit of the last class is not given, or both lower limit and upper limit both may not be given. That is called open-end classes. Here this should be avoided. Here when there is common class interval, okay, then to certain extent we may calculate what may be the lower limit and what may be the upper limit of the last class. But if the class interval is not common, then we cannot even estimate what may be the lower limit of the first class and what may be the upper limit of the last class. That is difficult. Therefore, here open-end classes must be avoided. Then these variables may be taken in ascending order or in descending order, but ascending order is preferred. Okay. Then it may be under inclusive method or exclusive method, but exclusive method is preferred. Here, why we have to prefer exclusive method? Here there is a technical problem in calculating class interval. Here, when we calculate class interval, the formula is upper limit minus lower limit. Okay. Now, if you apply that formula, now if you take this class 10 to 20, then what happens? Here upper limit is upper limit in the class 20 minus lower limit is 10, then class interval is how much? 10. Here class interval 10 means 10 values have to be recorded corresponding to the class 10 to 20. That means we record the values including 10. From 10 to 19 we record the values to the class 10 to 20. Okay. That means 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 10 values. That is equal to this one. On the other hand, if you take inclusive method, then if you apply the formula class interval equals upper limit minus lower limit, then what happens? Here take upper limit is how much? 19 minus lower limit is how much? 10. Class interval is 9. But here also we record the values corresponding to the class 10 to 19, 10 values. Means from 10 to 19, even 19 is included. Therefore, here there is a technical problem in calculating the class interval mathematically. Therefore, usually exclusive method is preferred. Now, from next chapter onwards, when you calculate averages or even in dispersion, standard deviation, quartile deviation, mean deviation, whatever it may be, they're all, when problem is given under inclusive method, first step is we have to convert those classes into exclusive method. Here in statistics subject, under which method exactly you have to calculate, that will not be given. By looking at the information, we have to find out under which method formula you have to apply. Therefore, you should be careful. Okay. Now, here it is before taking the formation of continuous frequency distribution, better let us know about the conversion of inclusive method into exclusive method. Okay. Now, for this, here the class interval need not be always 10. It may be 5, even I have told you if it is less than 5, you may take 2 or 4 as per the convenience, integral value. It may be 10 or 20 or 25, 50, 100, 200 or even 1000, means it must be in multiples of 5 or 10, that's all. Okay. Now, here when the variables are given under, classes are given under inclusive method, how to convert it into exclusive method? Here, first we have to find out the jump or the difference between the upper limit of the previous class and the lower limit of the immediate next class. Here the jump is how much? 19 to 20, 1. 29 to 30, 1. 39 to 40, 1. Isn't it? Now, here you have to take half of this jump or the difference. Here jump is 1, half of that means 0.5. Here it is very easy if you follow. Next what you have to do is, you have to subtract half of the jump means 0.5 from lower limit minus 0.5 and upper limit plus 0.5. That's all. Now here it is 10 minus 0.5, 9.5. 10 minus 0.5, 9.5. Upper limit 19 plus 0.5. Next 19.5. Next 20 minus 0.5. How much? 19.5. 29 plus 0.5. 29.5. 30 minus 0.5. 29.5. 39 plus 0.5. 39.5. 40 minus 0.5. 39.5. 49 plus 0.5. 49.5. Now you observe. Upper limit of the previous class is equal to the lower limit of the immediate next class. Now it has converted. Okay. Now you may have the doubt that here the jump is 1. You have taken half of that. Here you have to follow the same rule. By chance, if the problem was given like this, 10 to 18, 20 to 28, 30 to 38, 40 to 48, then what to do? Here also same procedure you have to follow. You have to add, you have to subtract half of the jump from the lower limit and you have to add the same to the upper limit. Here the jump or the difference between the upper limit of the previous class and the lower limit of the immediate next class is how much? 18 to 20. Here the jump is how much? 2. Isn't it? 28 to 30, 38 to 40. Okay, jump is 2. Half of jump is how much? 1. Isn't it? Now, subtract 1 from the lower limit, add 1 to upper limit. Then what happens? If you subtract 1 from lower limit, then 10 minus 1. Okay, 10 minus 1. Lower limit 2 divided by 2, half of jump 1, lower limit minus 1, upper limit plus 1. Here 10 minus 1 and 18 plus 1. Next 20 minus 1, 28 plus 1. Here 10 minus 1, 9, 18 plus 1, 19. Then 20 minus 1, 19, 28 plus 1, 29, 30 minus 1, 29, 38 plus 1, 39, 40 minus 1, 39, 48 plus 1, 49. Now see the classes. 9 to 19, 19 to 29, 29 to 39, 39 to 49. Now observe, the upper limit of any class is equal to the lower limit of the next class. Okay. Now sometimes the jump may be even, 0.1 may be given. The jump may be given 0.1. Okay. Now in that case you should be careful. Half of jump, it comes to what? 0.05. isn't it? Then same procedure you have to follow. Lower limit minus half of the jump and upper limit plus half of the jump. Lower limit minus 0.05, upper limit plus 0.05, like that. Okay. Now, let us take the problem. Formation of continuous frequency distribution table. Okay. Now, here you are given the problem. This data is about the marks scored by 50 students. Now you have to for the continuous frequency distribution table. Here I have given the heading continuous frequency distribution for your reference. As I have told you in the examination, like that it will not be given, just this data will be given. You have to find out the lowest and highest value, and you have to find out the range. Depending upon the range, you have to decide whether to follow discrete or to continuous. If the difference between highest value and lowest value is smaller one, then we go for discrete, and if that is a bigger one, then we go for continuous frequency distribution. Now here find out the highest and the lowest. Now here the highest value is which one? Here it is 79. I think highest value is 79. Highest value 79, and take the lowest one here 20, 26, 25. Okay, the lowest value is 25. Now what we have to do is, one of the principles of classification is class limits should be in multiples of 5 or 10. Therefore here when it is 79, it is not in multiples of 5 or 10. Therefore you have to take the rounded off figure. Here when it is highest value, you have to take to the next value which is in multiples of 5 or 10. If you take 75, then the values above 75 will not be covered in the last class. Means you have to see that last class should cover this highest value. Then here it is 25, it is in multiples of 5, therefore you may take as it is 25. Now take the difference. The difference is 55. The difference is 55. Okay. Now next, first step, you have to find the highest value and lowest value. Next, we have to find the range. Here same. Here range is nothing but, if you take in the form of formula, range equals highest value minus lowest value, or we may say maximum value minus minimum value, both are the same. Highest value 80 minus lowest value 25, therefore range is 55. Now after finding the range, then under continuous frequency distribution means we come across classes. Now here you have to keep in mind the principles of classifications. Now under that, one thing is limits are to be in multiples of 5 or 10, then class interval must be in multiples of 5 or 10, then number of classes must be between 5, 7 and 15, and I have told you practically usually we prefer even 5 and 12. Okay. Now on the basis of this class interval, means we have to decide the class interval, then we will come to know how many classes we have to take. Or if you decide the number of classes, then range divided by number of probable classes, we will get the class interval. Okay. In both the ways you may decide. Here if range is divided by class interval, we get number of classes. If you divide range by number of classes, we get class interval. Okay. Now that you have to decide by trial and error method by keeping in mind the principles of classifications. Now, if you take class interval as 5, then if it is divided by 5, then you will get 11 classes. Now, if you don't want that much 11 classes, then we may take the class interval as 10. If you take class interval 10, then what happens? Number of classes range divided by the probable class interval, then you will get 5.5, means it is rounded off to 6. Even if it was 5.1, that is to be taken as 6. Here mathematical rule is not applied, because the value which is above that has to be covered in the next class itself. That when you work out the problem, that you will come to know. Okay, now here if you take 10 as class interval, then you will get 6 classes. I think that is ideal one. Okay, now we have to decide what is the lower limit of the first class. Here lower limit of the first class should cover the lowest value given in the problem. Here lowest value is also 25. Therefore, no problem, we may take from 25. Therefore, lower limit of the first class we may take as 25. If it was 24 or 23, 21, in that case, what we have to do? We have to take the lower limit as 20. We cannot take 25. Okay. Now, here lower limit is 25. We may take lower limit of the first class as 25. Then, what is the upper limit of the last class? The last class should cover the highest value given in the problem. Highest value is 79. Therefore, if you take 80 as upper limit of last class, this will be covered. Therefore, we may take the classes. Here you should keep in mind class interval is 10. That means lower limit of the first class is 25. Upper limit of the class is 25 plus class interval. Okay, this also must be known to you. Here upper limit equals lower limit plus class interval, and lower limit equals upper limit minus class interval. Okay, here lower limit is 25 plus class interval is, here we have taken class interval as 10, that is 25 plus 10, 35. Like that you have to take the classes. Okay, now here we have to prepare the continuous frequency distribution table. These are the distribution of students on the basis of marks. Okay, now here if you, as usual, as in case of discrete series, here also we take the variables. Instead of taking variables in exact value, single value, here we take the variables in groups or in classes. Then we are going to record the values which will going to occur or fall in the respective groups or respective classes, that we record with the help of tally bars. Then to take the frequencies, we count these tally bars. Okay, here the difference between discrete and continuous, there we put the tally bar corresponding to a particular value. Here we corresponding to a particular group or particular class. Okay, now here number of classes are 6 plus 1 and plus 1 for total, means here we have to take 8. Here first column is marks, that may be taken as X, and tally bars and total. Now here lower limit of the first class is how much? 25. Lower limit of the first class is 25. Now, class interval is 10. Therefore, upper limit of the class is lower limit plus class interval. Lower limit is 25 plus class interval 10. Therefore, upper limit is 35. Okay. Now, here one more thing you must keep in mind. Here it is given that just prepare continuous frequency distribution table. Nothing is mentioned. It is known to you. Under continuous frequency distribution, it may be formed, frequency distribution may be formed either under exclusive method or under inclusive method. Under which method it is to be prepared is not mentioned. Usually I have told you exclusive method is preferred. Therefore, here let us take under exclusive method. Anyhow, you have to write a note as method, which method is not mentioned. I preferred exclusive method. If in the problem itself, if it is given specifically form continuous frequency distribution table under inclusive method, then you have to follow that method only. Now, let us take under exclusive method first. Now, here exclusive method means what? Upper limit of previous class is equal to the lower limit of the next class. Therefore, lower limit of the next class is 35. And here class interval, as far as possible, class interval must be common. Here we have taken class interval as 10. Now, upper limit is lower limit plus class interval. Class interval is 10. 35 plus 10, 45. Next, here same 45 plus 10, 55. 55 plus 10, 65. 65 55 to 65, 65 plus 10, 65 to 75. Here, highest value is 79. Now, we cannot stop at 75. If it was 60 to 70, then 70 to 80, then we could get exactly 80. But here we have started from 25. Therefore, it is 65 to 75. Here highest value is 79. Therefore, we have to take one more class which covers the highest value 79, 75 to 85. Now 79, it lies between 75 and 85. Therefore, you may stop the classes at this point. Okay. In case of discrete frequency distribution, we put tally bar corresponding to each value of variable. Here, in case of continuous frequency distribution, we have to put tally bar corresponding to each class. Now, 28, it lies in the class 25 to 35. Therefore, 28, 25 to 35. 66, it lies in the class 65 to 75. 45, here 35 to 45, 45 to 55. It is exclusive method. Upper limit is excluded. Only lower limit is to be considered, included. Therefore, we have to take 45 to the class 45 to 55, not to 35 to 45. Okay. Now 68, 65 to 75, 70, 65 to 75, 38, 35 to 45, 26, 25 to 35, 29, there is self, 32, there is self, 60, 55 to 65, 29, 25 to 35, 42, 35 to 45, 37, there is self, 36, there is self, 50, 45 to 50, 66, 65 to 75, 62, 55 to 65, 45 to the lower limit, 45 to 55, 79, 75 to 85, 32, 25 to 35, 51, 45 to 55, 56, 55 to 65, 60, 55 to 65, 51, 45 to 55, 49, 45 to 55, 25, 25 to 35, 42, 35 to 45, 54, 45 to 55, 51, they sell 58, 55 to 65, 70, 65 to 75, 43, 35 to 45, 58, 55 to 65, 50, 45 to 55, 52, they sell 38, 35 to 45, 67, 65 to 75, 50, 45 to 55, 59, 55 to 65, 48, 45 to 55, 65. Here it is upper limit, it is lower limit. To the lower limit, 65 to 75, 71, 65 to 75, 30, 25 to 35, 46, 45 to 55, 55 to the lower limit, 55 to 65, 47, 45 to 55, 76, 75 to 85, 60, 55 to 65, 52, 45 to 55, 51, there itself. Now, take the count of tally bars. It is 8, 7, 16, 5 plus 4, 9, 5 plus 3, 8, 2. Now, take the total 10, 19, 19 plus 16, 35, 35 plus 7, 42 plus 8, 50. Now, here total number of values or observations given in the problem. In each column 5 values are there. There are 10 columns, 10 into 5, 50. Total is also 50. Okay. Now it denotes 8 students have scored above 25 marks but below 35 marks. 7 students have scored above 35 but below 45 marks. 16 students have scored above 45 but below 55. 9 students have scored 55 and above 60, below 65 marks. 8 students have scored 65 and above but below 75 marks. 2 students have scored 75 and above but below 85 marks. Now, in the problem nothing is mentioned whether you have to form this frequency distribution table under exclusive method or inclusive method. As per the principles of classification, one of the principles of classification is exclusive method is preferred to inclusive method. If nothing is mentioned about the method under which we have to form the continuous frequency distribution, then we have to follow exclusive method. But in the problem, if it is specifically given form continuous frequency distribution table under inclusive method, then what we have to do is here taking the range, deciding the class interval, deciding the number of classes to be taken, all are same, no changes in that. In both the methods all are the same. The only thing is here this taking the limits of the classes. Under exclusive method, how we take upper limit of any class is equal to the lower limit of the immediate next class. Okay. Under inclusive method, what is the procedure? Upper limit of any class is not equal to the lower limit of the immediate next class. That means here only the upper limit of each class will change. Means when it is asked to prepare under inclusive method, we have to take the classes in such a way that upper limit of any class is not equal to the lower limit of the immediate next class, but the class interval is the same. That means here we have to take 25 to 34, 35 to 44, 45 to 54, 55 to 64, 65 to 74 and 75 to 84. Now you see, upper limit of any class is not equal to the lower limit of the next class. Here we consider the values from 25 to 34. Here upper limit is included under inclusive method. Therefore, we consider if there is a value 34, we consider in this class itself. Even in case of exclusive method, we consider the values, we take like that only, because their upper limit is excluded. When it was 35 to 45, we have not taken 45 to the class 35 to 45. We have taken the class, we have taken that value to 45 to 54. Therefore, no change in these tally bars or in this counting. The change is only in taking these classes. Okay, now we have taken like this. Here, no instruction has given regarding taking of the size of class interval or number of classes. That is our discretionary. It is left to your option. Okay. Here, but anyhow, we have to keep in mind the principles of classifications. Now, the limits must be in multiples of 5 or 10, or class interval must be as far as possible common. Class interval must be in multiples of 5 or 10, those things. Now, here, and even number of classes must be between 7 and 15, and it is not rigid. Even you may take between 5 and 12, that flexibility is there. Now, here we have taken the class interval as 10. Here you may take even class interval as 5. Okay. If you take class interval as 5, then what happens? Here you have to take 11 classes. That's all. Now, here if you take class interval, the size of class interval, instead of 10, if you take as 5, then how to take the classes? That means you have to take the classes like this. Here lower limit is the same. Here lowest value is 25. Here you have to take 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65, 65 to 70, 70 to 75, 75 to 80. Now see the number of classes, 3, 6, 9, 11. Okay. Now here, now what you have to do? You have to put the tally bars, or you have to consider the values to the class 25 to 30, the values 25 to 29, to this class 30 to 34. That's all. Okay. Now, if you take class interval as 5, then how to take same if it is asked to form under inclusive method? Then how to take the classes means here 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49, 50 to 54, 55 to 59, 60 to 64, 65 to 70, 70 to 74, 75 to 79, 3, 6, 9, 11. Okay, now here highest value is 79 and upper limit of the last class is also 79. Here, in case of inclusive method, even upper limit is included. Here both the limits are included, that's why we call it as inclusive method. Therefore, this highest value is covered in this class itself 75 to 79. Therefore, you have to stop at the class. Okay, like this you have to take under inclusive method or exclusive method the class interval as per the convenience, keeping in mind the principles of classifications. Now here this is the problem when no instruction has given about the size of the class interval or number of classes, nothing is mentioned here. That is as per our option. By keeping in mind the principles of classification, we have solved the problem. In the next session, I will going to take the problem. If some instruction has given directly or indirectly, the instruction may be given directly or indirectly. If some clues are given, then also we have to follow that instruction. Okay, that I will take in the next session. Thank you.